calculus. What values is y equal to the square root on rational function differentiable? All right. So we've got all this to the 1/2. So this rational function to 1/2. So use power chain rule, differentiating y with respect to x. That's going to be 1/2 times the square root 1 minus x over 1 plus x squared, and negative 1/2 times the derivative here. Whoops. That way. Here. So 1/2 of this to the negative 1/2 times the derivative there. So the derivative of that going to be quotient rule minus, and then on the bottom 1 plus x squared squared. Now the bottom to top, that's going to be 1 plus x squared times the derivative of the top, which is just negative 1. Then top to bottom times the derivative of the top, or derivative of bottom. Bottom to top, top to bottom. That's 2x. Alright. And so this can all go on the top of the fraction. This can go on the bottom of the fraction. So let's look at, let's clean this up a bit. Negative 1 times this is negative 1 minus x squared. And then minus, well, we don't really need those parentheses, do we? But we'll do minus to show where the, sorry, it says minus 1 minus x minus, oops, no times 2x. I forgot to multiply first. Humble apologies. That would be distribution here. This would be a 2x. This would be minus 2x squared. That's our distribution. So minus 2x and plus 2x squared. That stays there. This goes on the here. That's 1 plus x squared squared. So that's kind of the top of the fraction. That's all over. So this kind of went on top of that because this is negative. It'd be 2 and the square root of this right here, 1 minus x over 1 plus x squared. Alright, so this went here, this went there, this went there. Alright, can we clean this up any? Negative x squared and 2x squared just goes to positive x squared. X squared minus 2x minus 1. That'll be x squared minus 2x minus 1. Nothing leaps to mind as factors of that. Certainly not 1 plus x squared anyway. I think this is going to stay as it is. So we have that. So for what values is this differentiable? And then we want the top of the fraction. Clearly x cannot equal positive or negative 1 here. Because that would give us, oh no, I'm sorry. They both give us positive 1. So that's perfectly fine. There are no restrictions here in the bottom of that fraction. Here, again, no restrictions with the x squared. However, all this can't be negative. No way the bottom can be negative, so we just have to look at the top. When can the top ever be negative? So when is 1 minus x less than or equal to 0? That'll be our restriction. That's a restriction on this. Let's go ahead and make this greater than, because that will simply answer our question. We want to see when is this valid. So top's always valid, this is always valid, that's always valid. This is valid when 1 minus x is greater than 0. And so then we just have 1 is greater than x. So for all x, and we could do equal to, couldn't we? No reason that couldn't be Oh no, we couldn't do equal to, because if this top is 0, square root of 0 is 0, 2 times 0 is 0, that's 0 in the denominator of a fraction. So you have to be strictly greater than x. Oh, 34. Now we're looking for when this is differentiable. We've got 2x minus 7, negative 1, and x plus 5. Alright, that's not so bad. This is negative 1, so we're just looking at a plain old rational function that looks like this. X plus 5 over 2x minus 7. So when is this differentiable? We'll find out when we differentiate it. Take dy dx. Bottom to top to the bottom. 2x minus 7. Derivative of the top is just 1 minus top. Derivative of the bottom. All of the bottom squared. So the top, I'm not even going to bother simplifying it. Because it's always defined. When is this a problem? When 2x minus 7 equals 0. So this is our prohibition right here. This is when we're not defined. That means when x is equal to 3.5. We're not defined. X may not equal that. Uh, 35. I was trying to find dy dx when our function looks like, or not really a function, but our equation xy plus 2x plus 3y equals 1. This isn't bad. Implicit differentiation. We've been doing this for a while now. So this is product rule. So the first times the derivative of the second plus the second times the derivative of the first. That's taking care of xy. And derivative of 2x is 2. Derivative of 3y is 3 dy dx. Equals 0. Keep our dy dx on one side, everything else on the other. So we have x dy dx plus 3 dy dx equals negative 2 minus y. Factor us out. Dy dx x plus 3 and then we can divide both sides by x plus 3. Find our function. I like to put the variable first, just because. And there we have it. Dy dx equal to negative y minus 2 over x plus 3. See, that was 35, 36. 36, we have 5x to the 4/5 plus 10 y to the 6/5 equals 15. So no surprises here. 4/5 times 5/5 is 4. 5/5 is 1. That's x to the negative 1/5. And we subtract 1 from 4/5. 6/5 times 10 is going to be 12. 6/5 minus 5/5 is 1/5. We still have dy dx. Equal to 0. So now, subtract this off. So y to the 1/5 dy dx equals negative 4x to the negative 1/5 and dy dx. Now this is multiplied, so we need to divide. So that's going to be negative 4x to the negative 1/5 divided by 12y 1/5. I'm going to clean this up a little bit. The x to the 1/5 I can move down here, and the 4 and the 12 cancel to make 3 on the bottom. That'll be negative 1 over 3. So it's 4 and the 12. Keep the negative. The negative exponent goes down the bottom. So that's x to the 1/5, y to the 1/5. And we can change that. Do negative 1 over 3. The fifth root of xy. Feel free to have stopped here. I'll do just fine. Could have even done negative 1/3 xy, negative 1/5. Either of these are fine, but that works for us. Onward and upward to number 37. Closing in on the halfway mark. Go 40. Square root of xy equals 1. This is a nice half a chain rule. So this is xy to the 1/2. So that makes 1/2 xy negative 1/2 times the derivative of the inside, which will be the product rule. So the first times the derivative of the second, plus the second times the derivative of the first, which is just 1. There's derivative 1. Alright, so we're going to get this all out by itself. 1/2 can go because we just have 0. And multiply both sides by square root of xy. That can also go. Well, now we're left with this. That means x dy dx is negative y dy dx equals negative y over x. I'm reasonably at home with that. There are a variety of values for x and y which can make that original. Yeah. That'll work for us. That's what the book likes to see. That's perfectly fine. Suppose we could have squared both sides at the beginning. Yeah. Would have been reasonable. Number 38. Which we'll save for next time.